Okay, according to Kepler's third law, the Kepler's third law says the square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit. We call this as law of orbits. Okay, how to identify and how to use the formula? First of all, we should know that any planet, going around the sun, they are moving in elliptical idea. These objects that are going around the sun, or the planets going around the sun, will have their centripetal force towards the center of the sun. And also, they will follow the universal gravitational system, where they'll have their gravitational force also around the sun. All right. So there are two forces acting, whereby the two forces are equal to each other. The centripetal force of the planet towards the center of the sun is equal to the gravitational force. All right. This is the formula for the gravitational force: universal gravitational constant value, mass of the sun, mass of the earth, and the radius center to center. Centripetal force, mass of the earth, the speed, orbiting speed of the earth around the sun. All right, the linear speed, the orbiting speed of the earth around the sun, and the radius, center to center, center of sun to center of earth. When the centripetal force is equal to the gravitational force, we make the equations equal. As we take out the mass of the earth, we are left out at speed square over r equals to universal gravitational constant value, mass of earth over r square. All right, the radius. As we know that the linear speed of the earth going around the sun is the distance of the orbit, 2 pi r circumference over the period of orbiting. So this is the earth going around the sun. The distance it's going to travel is 2 pi r. All right, and the time taken to complete one orbit is called the period, which is 2 pi r over t. So as we move on from this part of the formula to the second step here, we bring the r up here, we get here gm over r, and we substitute the v value to 2 pi r over t. As we solve this, we get 4 pi square r square over t square equals to gmr. And we bring the r up here, we get 4 pi square r cube equals to t square gm. And we rearrange the equation, t square gm equals to 4 pi square r cube. The next step that we will do here is that we get t square gm 4 pi square r cube, right? So bring the gm down. So we arrange all the constant values in order. So we get t square equals to 4 pi square over gm, bracket, open and close, and r cube. So we have a relationship now to show that the t square is directly proportional to the r cube. The t square is directly proportional to the r cube. Why this is important? Because we can rearrange the formula again, if you see here. So t1 square over r1 cube is equals to 4 pi square over gm. We also rewrite t2 square over r2 cube is equals to 4 pi square over gm. And since this 4 pi square over gm is a constant value, we remove it and we make this equation equal to this. So t1 square over r1 cube equals to t2 square over r2 cube. How to use this equation? So Kepler's third law can be used like this. See here. Let's say in any system, this is the center star. Let's say this is the mass of the center star, like our solar system, the sun. This is the radius of the first planet. And this is the radius of the second planet, the distance between the center to the center, center of the planet to the center of the sun or the star. All right, R2, R1. And this is T1, the period taken by the first planet to orbit in its own orbit system. And this is T2, the time, the period taken by the second planet to orbit its own system. By using Kepler's third law, we can use the formula T1 square, the period of the first planet, square over the radius r cube is equivalent to 2 square over R2 cube. So this equation can be used to identify period of orbit, radius of a system where there is like solar system, sun with other planets, or we can go to other planets also. For example, planet A with its first moon and second moon. Planet A with its first moon and second moon. So you just take the period of the first moon and the radius distance, take the period of the second moon and the radius distance, or you can identify, you can calculate and measure by using this formula. So Kepler's third law is very important. It explains that the square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit. Then the square of the orbital period of any planet is directly proportional to the cube of the radius of its orbit. So this idea can be used for any other solar system, the center sun or star with other planets. Just use the formula. Or we can even use on Earth, the mass of Earth, the first satellite going around and the second satellite going around. So this is the period of the first satellite and its radius distance. This is the period of the second satellite and its radius distance. This is how we use Kepler's third law.